Okay, so let's try one more example. So in this example, I have a balloon filled with 600 milliliters of helium at room temperature, which is 25 degrees Celsius, sits in a hot car at 55.7 degrees Celsius. What is the final volume of the balloon? So I need to have my table set up. And so that means I need my pressure, volume, number, and temperature. And so with this, I'm going to have my initial, or starting, and my final. I'm also going to have the effect, just like we did on our worksheets. And so, by looking at this, I can tell that since the balloon is filled with 600 milliliters, milliliters tells me that that's volume. So 600 milliliters is my initial. It tells me that my temperature that I start at is 25 degrees Celsius. Except for there's a problem with that, because do we do calculations in Celsius? No. So what we need to do first is we need to convert Celsius to Kelvin. And we do that by having 25 degrees Celsius plus 273.15 equals 298.15 Kelvin. Remember, there is no degree symbol with Kelvin. It tells me then, so now I have 298.15. Then it tells me that it sits in a hot car at 55.7 degrees Celsius. So again, I'm going to have to convert my Celsius to Kelvin by adding 273.15 to the temperature in Celsius. When I do that, I get a temperature of 328.85 Kelvin. Then it asks me what is the final volume. So that's going to be my question mark. This tells me that my pressure and my number will be constant. Pressure is constant because it's a non-rigid system. And my volume, or my number, doesn't change because it's a closed system. When we look at our graphical relationship, we know that when temperature increases, so does my pressure. When temperature decreases, so does my pressure. It's a direct relationship. So what that means is now, looking at my temperature, it went from 298.15 to 328.85. It increased. That means that my volume should also increase. And by doing this, I've now set myself up so that the math is pretty easy. My 600 milliliters is going to be my given because I don't know what the final is. And so, since it's my given, the given always goes over 1. Then I need to multiply it by a ratio of Kelvin to Kelvin. The question is, which ratio should I use? Should 298.15 go on top, or should 328.85 go on top? I need my volume to increase. So the ratio that gives me an increase when multiplied by pressure is going to be when 328, the larger number, is on top, and the smaller number, 298.15, is on bottom. When I calculate this out, I get a volume of 661.78 milliliters. And when I look at this, it does in fact increase from 600 to 661.78. So that tells me that I set up my ratio correctly and that that is my final answer. particle level reasoning is that the temperature is increasing, which means the kinetic energy is increasing, which means particle velocity is increasing, which means number and force of collisions is increasing. Because it's a non-rigid system, this does not change the pressure. Instead, what it changes is the volume, because my system can change. So it increases the volume. Now I ask the question, I have a part B here, and I say, if the maximum volume of the balloon is 650 milliliters, what will happen to the balloon? And so in this, my balloon reached a size of 661.78 milliliters. And so what that tells us is the pressure inside the balloon at this point is going to be much greater than the pressure outside the balloon. So in the previous problem, we weren't changing pressure, but in this case, it's asking me, I'm at 650 milliliters, I'm at a higher volume, and because of that, the maximum volume is at 650, and I'm at 661. And so when we talk about our volume, and we talk about our pressure, sorry, I'm thinking of the wrong thing. When we talk about this, we talk about the pressure inside the balloon versus outside the balloon. So my pressure, it can only withstand so much. So in this case, let's say that it can withstand 3 collisions on the inside. We have 2 on the outside. Well, now, since it's in the hot car, these particles are going to speed up. They're going to move a lot faster. So I still have 3 particles. But because their temperature increased so much, there's going to be more collisions, even though there's still just 3 particles. That means that my pressure inside is going to be greater than the pressure outside, to the point, and it breaks my system. It breaks the system because once the balloon pops, there's nothing I can do to bring it back to its normal shape. And so since the system breaks, that means that it has exploded, because the system broke due to the pressure inside being greater than the pressure outside, so the particles escape the system by moving out of the system.